Between the main poles are small auxiliary poles known as interpoles. There is an interpole for every field pole in a DC motor. Depending on the design, interpoles may be constructed from laminated sheets or as solid pieces. Their primary function is to improve commutation by counteracting the effects of armature reaction. Interpoles are also wound with conductors. But unlike the main field windings, they use thick conductor bars with very few turns, as they carry the full armature current. Components are the winding, the bobbin, and pole core. And yes, these two have shims that adjust the air gap and magnetic strength delivered to counter the distortion of the main field flux caused by armature reactance. Unlike the main field windings, the interpole winding uses thick conductor bars with very few turns, as they carry the full armature current. Depending on the design, interpoles may be constructed from laminated sheets or as solid pieces. Another important feature in higher power DC motors is the addition of compensating windings. These windings are embedded in axial slots cut into the pole shoes. Like interpole windings, they are made using thick conductors, as they also carry the full armature current. Interpoles and compensating windings are connected in series with the armature to ensure their magnetic effect varies proportionally with load.